Hello, and welcome to our presentation on climate change, landscape change, and Lyme disease in the United States for the 2017 Watson Analytics Global Competition submission. My name is Tracy Carr, and I will be presenting our Lyme disease dashboard on behalf of my team from the University of Maryland University College. This project will explore the relationship between key climate change indicators and reported cases of Lyme disease in the United States. Lyme disease is an illness transmitted by certain species of infected ticks that live on host animals and spread the disease through bites. The incidence of Lyme cases in the United States has nearly doubled since 1991 and has become the most common vector-borne illness in the United States. Cases are currently still limited to specific geographic regions within the United States, primarily the Mid-Atlantic, New England, and North Central regions. However, the volume and spread of those cases has grown over time. Climate change has become a factor in the transmission and incident rate of Lyme disease because of its likely influence on the survival of the tick population in a growing land area of the United States. Studies have also linked temperature extremes and precipitation patterns to the prevalence of the vector-borne disease. Other factors potentially contributing to the rise in the disease are environmental factors such as changing ecosystems and landscapes. Human behavior, like time spent outside, as well as the coordinated response to the disease and changes in the ticks and bacteria causing the disease, are to be considered as well. The main sources used for our project consist of 1. NOAA, the National Oceanic and Atmospheric Administration, 2. the U.S. Census Bureau, and 3. Center for Disease Control. These datasets were combined using Microsoft SQL Server to comprise two different granularities of data. 1. A national level dataset containing data for the United States as a whole, and 2. A county level dataset focusing specifically on the New England region, where the fastest growing number of Lyme disease cases exist. Our team developed a dashboard in Watson Analytics exploring the role of climate indicators in reported cases of Lyme disease, including data refinement, exploration, predictive modeling, and social media analytics. The focus will be to explore known linked indicators of temperature and precipitation, determine effects of additional climate change indicators, and relate variables measuring our changing landscape with the Lyme disease spread. Now let's take a look at the dashboard. The dashboard consists of 8 tabs. The first 5 tabs explain national related data. The next 2 tabs dive into county level data, and the final tab contains Twitter data on a national level. In the National Lyme Disease tab, we get an overview of the increase of Lyme disease in 3 different visuals. The bar chart on the left depicts the change in reported cases of Lyme disease by region and year. The map in the upper right displays the country and provides hues of blue to portray where the abundance of cases have been reported. The concentration in the Northeast is very noticeable as compared to the remainder of the country. You can select any region to get a detailed view of this area. You can also select a single year and region to filter in even more. The National Lyme Counts tab allows us to drill into total reported Lyme disease cases in several different ways. Clicking on region, New England, changes the counts and the definition of the states. We can also look at a particular year. The National Environmental Drivers tab uses Watson's built-in spiral visualization showing key predictors for Lyme cases. The number of combinations of environmental indicators have a strong predictive strength. A total of 47 different combinations have a predictive strength of 95% or more. Many include forest area, building permit, precipitation measurements, and temperature measurements. Key individual indicators include forest area at 88% and population at 85%. The Environmental Indicators tab is less interactive and more informative. On the left, you can see the positive relationship between the percent of land area experiencing extreme precipitation events and the number of cases of Lyme disease. The graph also identifies a potential negative relationship between the amount of methane in the atmosphere and the number of Lyme cases. On the right side, you can see as the percentage of land area experiencing unusually high summer low temperatures grow, so does the number of cases of Lyme. Higher incidence rates of Lyme also appear to correlate with increased forest coverage, as measured as a percent of U.S. land area. Building permits were identified as a potential variable of interest and possibly a measure in tracking deforestation when tracking the spread of Lyme disease. As you can see, there is a complicated relationship between Lyme disease and building permits. While both building permits and Lyme cases increased steadily from 1990 through 2006, the economic downturn in 2007 saw a drastic reduction in building permits, while Lyme cases increased significantly for 3 years in a row, which had never occurred in the past. Focusing specifically on 4 states in the New England region, you can see how the spread of Lyme has increased from 2000 to 2015. Clicking on a specific state provides a more in-depth visual of the region. A decision tree was built in an attempt of predicting the number of cases of Lyme disease. The tree has a predictive strength of 52% with an overwhelming predictor being population. To try to understand population, an additional decision tree was created which had a predictive strength of 64%. Details can be seen by clicking on any of the leaf nodes. Finally, Watson was used to analyze the hashtags Lyme, Lymes, Lyme disease, and Lyme's disease. Sediment, geographical location of tweets, and associated hashtags are displayed. Clicking on any component of the dashboard filters the other areas. Clicking on the negative sediment causes the map and word cloud to only display negative tweet data. Selecting New England filters the map and again the word cloud and sentiment to only provide tweets from the New England region. Conclusions can be drawn that there is a clear correlation among many key environmental indicators and the spread of Lyme disease. Milder climate, shown by warmer seasonal temperatures, may contribute to the spread of Lyme disease. Forest area and building permits indicate that increased forest density may also contribute to the spread of Lyme disease. Based on these findings, public education on the prevention of Lyme disease should continue and will likely increase in the area of focus, New England, Mid-Atlantic, North Central, and adjacent regions. Thank you for watching our presentation.